Hey there, my gorgeous friends on the internet. Today's episode is all about Squizzle. We're going to learn how to set up PostgreSQL from scratch. I'll teach you everything about creating tables, creating databases, foreign keys, joins, all the different joins, and everything else there is to it. I've been running this channel for about 7 years or so, and I think especially in the last year, I started really regretting focusing so much on JavaScript, especially because I started expanding my territory. I've been learning Go, I've been learning Python with machine learning, learning everything about linear regression and all that good jazz. And I think that could be more valuable to the viewers here rather than what's Prisma up to, what kind of feature they added. Who cares, in 2 weeks it's all gonna change anyway. So focusing on more fundamental technologies like actual SQL, how does it work, everything that there is to it, I feel is more valuable. So you know what they say, ORMs come and go in the JavaScript ecosystem, but hey, Squizzle stays. Squizzle always stays. So yeah, hope you enjoyed this little mini series. It's going to be probably 2 or 3 episodes on this. We're just going to chill back, got an energy drink if you have a cup of coffee. Let's sit back, let's learn some SQL. Okay, so the first step is to get PostgreSQL installed. So one way you can do that is to head over to postgresql.org/download, and here you can choose your operating system. So if you're on Mac, Windows, they have this installer that you can just go through. And once you go through this, I also recommend getting the latest one, so version 16. And then once you install this, they'll automatically give you this SQL shell here that you can just open it up, create a database, and start running SQL commands. So that's one way, but if you want to be much cooler, what you can do is run everything through the Windows Linux subsystem. So that way, we just set up a Linux environment and just install PostgreSQL through there, which is much more fun. And you get 10 cookie points if you do that, and you're going to be 100x more respected in the web development community. So we'll do that instead. So the way you can do that is open up a terminal. So wherever you are, if you're on Windows here, you can install the Windows Linux subsystem with just a super simple command now. You can just do WSL -- install like that. Okay, let's enter. And as you can see, it's already installing Ubuntu. So it's gonna ask you to enter a username. So let's just do develop by Ed here. And also a password. Now, when you start typing this, it's not gonna pop up because why would they help you like that, It's always good to confuse the user. So start typing your password, but again, it's not gonna show up, so don't freak out. So type it in and just hit enter. Okay, and then you're gonna need to do the same and then just pray that you did it correctly. And we did it correctly. Okay, so done. We can close this up now. Installation has been successful. Lovely, and as you can see, boom, we are running in the Windows Linux subsystem. But we can close this up, and the way I like to do it is just open up a terminal here. And the way I have it here is, let me just close this up. As you can see, I have git bash here set up and all of this jazz. But I like to go to settings here and just set this Ubuntu to the default now. And now if you check on your Windows here, as you can see, it just added Linux there with the Ubuntu added. So perfect, so we are up and running here. So the first step we can do is just make sure all the packages are up to date, and then we can install PostgreSQL. So let's run the command sudo apt update, and this is gonna just install all the packages and re-update them. So here we'll need to type in the password that we initially added, and there we go. So let's just wait for this to install, and then we can also add the PostgreSQL package. And there we go, we are up to date now, so we can start installing our package. We can run the command sudo apt install, and we can say PostgreSQL like that. And then one more we need to do is PostgreSQL-contrib like that. So let's install on this, and you're gonna need to add a Y here. It's gonna say, hey, I'm gonna take up 162 megabytes of this space. Is that okay? Just say okay. It's just hilarious because when you download the game these days, it's 200 gigabytes. So it's just a bit funny that they give you a warning for 150 megabytes. But anyway, let's install this. And there we go. Now we have PostgreSQL installed. So we want to make sure that this Postgres is actually running on our machine. Okay, it's not pause, the service is actually working. So the way you can check that is you can type in sudo service and you can say PostgreSQL like that. And then you can check the status on this. So if we hit enter, as you can see, it's active. So that's perfect. In case it's not active, well, we can stop it as well if you just say sudo service PostgreSQL stop. And now when you check the status again, as you can see, it says inactive parentheses dead. Jesus, that's a bit dramatic. But okay, let's go with dead. So let's start the backup. As long as this is start, there we go. As long as it's running, you should be good to go. So if we check status again, active. So one more thing before we can connect to PostgreSQL is I want to set a password. So the way you can do that is write sudo passwd, and then you can say postgres like that and hit enter. So I'm going to type in a new password here. Make sure again you remember this, otherwise you won't be able to access it. And there we go. Password updated successfully. So now to actually go inside and run the service, you can say sudo -u, and you can say postgres psql like that, psql. Hit enter, and look at that, we are in, ready to go. So let's get started creating a database. So you can view all the databases you currently have in your list by typing \L. And as you can see, that just pops everything up here. We have one Next Commerce here, Postgres, template 0, template 1. Now I just created this now. Let's say we have like a Next.js application or something. If you want to create another one, you just write the command create database like that, and then you give it any name you want. So let's do test, for example, right? And boom, it created a new one like that. So if I do L again, \L, as you can see, we have test, Next Commerce, Postgres, template 0, template 1. So that's it. That's your first like SQL command that we've written. What is SQL anyway? SQL stands for a structured query language, and it's just commands that you can give to a database to actually like converse with it, whether that's to query data, to modify data in your database, or anything else. Okay, so it's just a way to communicate with the database. So create any database that you want with any name you want, and the way you can connect to it is by typing \C like that. I like to imagine it as like connect. So \connect to which database. So in this case, it's Next Commerce like that. Let's go in this one. And as you can see, it says now you are connected to Next Commerce as user Postgres. So that's like the default username they usually give you is Postgres like that. Now you probably heard of the term NoSQL as well. This is SQL. And the difference is, I don't want to really get too deep into it. Just so you know, you're on the right side of the fence. SQL is probably what you want to learn most of the time anyway. And once you really understand SQL, then you're really going to understand where like NoSQL could be beneficial. But in our cases, most of the time we're looking for making like web applications, right? Like a e-commerce website, for example, where you have users and the users has, you know, like different orders, for example. So there's these relationships that you can connect your tables and your data. And that's what SQL is really good at. It's really good at creating structured data that relates to each other. Whereas NoSQL is kind of a bit more like a free form where you can dump in data there and you are good to go. So that's essentially what we're going to do in SQL. You're going to have a database, and within that database, you're going to have a bunch of tables that relate to each other. So again, in the case of like a e-commerce website, you'd have a table for your users, you'd probably have a table for your products that you sell, and also for the orders that the users can purchase. In this case, let me show you a simple example that we're gonna set up. Let's say we have a table for games, okay? Just like new games that are popping up, and let's say we wanna save these to the database. So you're gonna have like an ID here, for example, maybe a rating that this game has, the name of the game, the genre, and maybe like an image associated to that. So that's basically like the columns that you can create in a table. And then after that, you're gonna have a row here. So that's like the data that actually gets added. Or these are also called records. So in this case, we have one record in this table that has the ID of 1. The rating of the game is 10. Diablo 2, great, really great game. Haven't played the new remastered version of it, but let me know if it's really good. We have a genre here, RPG, and then some image URL, right? And then you can have multiple records added here. So we have 1, 2, 3 records, Empire Earth, League of Legends, whatever. Okay, so kind of this is the shape of a table that we can set up. And then we are gonna get into making another table and also see how that relationship works. So let's create this table. and get started. So let's head back to our terminal here. And to create a table, we can just simply run the command create table like that, and then give it any name you want. So we call this games, right? Now we can add a pair of parentheses in here, and this is basically where we define the columns. So if I have an ID, and basically every table should have an ID column, because you want to identify these records by like a unique keyword. So when you're querying the data back, you're fetching the data back, if you don't have an ID, the only other ways you can still retrieve it based on like the name of it, but an ID is usually going to be, always should be actually unique, okay? But for now, let's just do an ID simply like that, and I'm gonna say int, okay? Which stands for integer, and an integer is just a number that could go from minus, what was it, 2.14 billion to plus 2.14 billion. If you pass that number, it's gonna error out and it's not gonna work, okay? But that's an int. We are also gonna set up a name, so let's do a name. And for this, I'm gonna do a var char like that, or var character, variable character, right? This is just like strings, right? So characters. Now I can add a value here, 50, and that basically means the name can have up to 50 characters and like string value in here. If it's past that, then it's gonna throw an error again. And you can set this we can go up maybe to like 100, that's a bigger value. And then let's add a comma, okay? So that's 1, 2, I believe we also added a genre here, genre like that. Let's do the same for this var char 100 like that. And let's also do an image URL here. And this is gonna be the same. This is gonna be a var char of 100, maybe 250. Can be a long link. Usually you're saving like your images through like an S3 bucket or whatever, and then you're actually just passing the link that's gonna like link to the S3 bucket. Okay, so you're just saving the URL for it, and that's what you're gonna see most of the time happening. Whether you're using Cloudinary again, you're gonna upload it through their service, and they're gonna give you the link, and then you can take that link and save that to your database. But that's it. Okay, so you're create table, right? You give it the name of the table, and then in parentheses, you give it all the different columns that you want to give it. So in this case, we have 1, 2, 3, 4, and then what kind of like data structure is it? Is it an int? Is it a Boolean? Is it, you know, an enum? Whatever. Okay, so let's hit enter on that, and we have a syntax error. So let's head back and see what we messed up. And it looks like I just wrapped this var char inside the parentheses for some reason, so let me just get rid of that like that. Okay, so let's enter again. And this should be, the 250 should be in the parentheses. There we go. Let me add that, that's what I wanted in the first place. Okay, let's hit enter again. And there we go, we created a table. Lovely, well done. So to visualize this table, you can do a \d like that, and then the name of the table. So this is games, right? Hit enter, and there we go. We can see all the columns, ID, name, genre, image, URL. Cool. If you want to see the data inside, so if you want to query the data, you can do select. I'm going to add a star symbol, which basically means everything. So select all the columns. Select all the columns from the games table. And that's it. Hit enter, and there we go. As you can see, we have all the columns here, about 0 rows. So 0 records have been brought back because we don't have any data included within it. Okay, so there we go. That's how you can select all the data back. Now let's see how we can actually push a new record inside our database, our table, I should say. So we'll say insert into, we'll say into the games. And here in parentheses, let me just not do this for now. Let's just say values here. So insert into the games table, the values, and then you do parentheses. So for the ID, let's just do 1 for now. The name here, I'm gonna do, let's do Dota 2. For the genre, I'm gonna do MOBA. And the image URL, let's just do https some image.jpg. Okay, and there we go. Add the parentheses, finish the parentheses, and add the semicolon at the end. If I hit enter, you're gonna see the message insert 01, so 1 record has been inserted into the games table. So I just do the up arrow twice. I can go back to select everything from games again, and if I hit enter, there we go. Look at that, we have 1 record added. Cool. Super simple, right? Now the select star from games, you can specify if you only want to like return specific columns. You might not want to get all the data back. So here you can say select name and genre, for example, from games. And if I hit enter, as you can see, it's only going to return those 2 columns for us, which is pretty cool. Let me just head back to this insert example because there's a little problem that we have with it. So let's just go back. Let's just reinsert this. Insert into games, the values. I'm gonna open up a pair of parentheses. So let's do 2 this time. For the game, we'll do Overwatch. There we go, comma, shooter, and the image URL, https someimage.jpg, right? Okay, so here's one more thing we can do with this. If you head back here to insert into games, right after games, you can add another pair of parentheses and you can define like what kind of columns you want to add the values to. So I can say I want to add to the ID, to the name, to the genre, and to the, what is it, image URL. Okay, so now if you compare like this parenthesis here to this parenthesis on the right side, you can kind of imagine these as like parameters. So the ID is going to correspond to the first value added here, so 2. Name is going to be the second, genre third, and then image URL fourth. Because the nice thing is now, if you define it here in parentheses, you can move these values around. So let me just hit enter to add this once, and then I'll reopen this and check this out. I'll just add name first and then ID. So I'll move them around. Okay, so now when I add the values in here, now the name should be the first one. So it should be Overwatch now. Okay, so Overwatch as the first one. Oops, there we go. And then the second argument should be the ID here. Okay, so you can do that. You can switch these around, or you might want to insert data and you might only want to insert into the name and the ID. Well, that's how you can do it. You can open up these parentheses and define the data that you want to add. So let's just change this to 3. I'll change this to a different game, Manor Lords. How is this? If anybody knows, let me know, because I really am interested in playing strategy games. Okay, there we go. Okay, so we just switched. Name is now Manor Lords as the first, ID is the second, so it's going to be 3, strategy as the third, and then the image URL. So if I hit enter, as you can see, that still works. So if I go back and select all from games, as you can see, it still got inserted correctly. Now, one problem that we have with this current table is we can insert data. Let's just say I want to insert games. I can say games here. I want to insert into the name and the genre, for example, the values, and I'll just say test here, and then RPG. Okay, so if I hit enter now, that works fine. But what you don't want to have in a database is a record that doesn't have an ID associated to it. All right, every record should have like a primary key, a primary identifier that's totally unique within this table. Okay, there shouldn't be any other record with the same ID. And currently, we can add records in here that just don't have any ID at all. Okay, so one thing we can do is to enforce, just enforce the user or whoever adds the records inside. This can be through like a UI, right, or wherever. In React, you can create a UI, and then when you post it to the database, it should throw you back an error and say, hey, wait, you didn't provide an ID for this, so I cannot create that record for you. So there's 2 options you have here. One is add basically a not null to the ID. Adding the keyword not null when we create the table, it won't allow us to insert any new records without having defined, an int, all right, for the ID. Now we already created this, so what I'll show you is how we can modify this instead. We can alter the table and add that not null to it, and then we can look and see what happens. So first, let me also show you how we can delete this record here. So let me show you one thing that you might do, and then you're gonna be like, oh God, what happened? We're gonna say delete from, and we're gonna say games, like that. Now, if you run the command like this, This is gonna delete all the records from you because it just says delete from games. Well, everything, just get rid of everything. So here's another new special SQL keyword that we can use. It's the where, okay? And this is like a comparison. It checks to see kind of like the criteria. It should like filter out and delete only those specific ones. So I can say where the ID equals whatever, 4, or let's do 3 here because we don't have a 4, right? We have Manor Lords. I want to get rid of Overwatch actually. Buy Overwatch. So where the ID equals 2. So if I hit enter, as you can see, we have 1 delete successful. And there we go, it's gone. Okay, now let's go back here. What if I want to get rid of this? So now we'd have to do it by the name or by the genre. Again, this might be a problem depending on the application. You might have, you know, another record that has the same name, so you might accidentally delete multiple records. So that's what you usually want to do it by the ID. But in this case, let's just get rid of it because there's no other way we can get rid of it. So let's say where the name equals to test, like that. Okay, and there we go. When we hit enter, if we select the games again, it's deleted. And like this is what happens if you do delete from games and you just hit enter. Look at that, it just like cleared everything out. So be careful with that. Okay, don't like, make sure you add your where clause, otherwise it's not gonna be a good time. Okay, so now what we want to do is there's 2 things we want to do here with the ID. So we essentially want to modify the ID table to either be not null, which means we cannot pass, like we need to pass in a value here in the ID, otherwise the new record will not get inserted. And the way you can do this is, you'll see this in the future. I'm going to make an episode where we're going to be working in React. I'll show you how to work in SQL there as well. We'll need to like generate some sort of UUID, and then we can pass that down here. Or what you can do is also make this ID a primary key, which means that, and add a serial keyword to it, which means that it's the PostgreSQL is going to do it for you. It's automatically going to increment, start from 1 and all the way up. Okay. So let's see how we can also drop the ID column and just recreate it. So we can say alter table. I want to alter the games table here. And I can drop the columns, or column, I should say singular, ID, like that. Hit enter. And as you can see, that altered the table. So if we go back here and output this, we do a D games, like that. Sorry, / D games. There we go. Look at that. We have name, genre, and image URL. Okay, so we got rid of that. Now we can also alter these, for example, like image URL. So to do that, I can do alter table, and I can say games, and I can say alter column. Let's say I want to alter the column image URL, and I want to alter it to varchar, let's do 200 this time, and hit enter. One more thing we need to add here is after the image URL, you can say type. Okay, so the type is going to be var character 200 now. So let's hit enter, and as you can see, the table got altered. So if we output this again, as you can see, image URL is only 200 now. Now let's add that ID column back, but make sure that it has the serial and the primary key associated to it. So we're going to say alter table in the games, and I want to add a new column this time. So we can say add column, I can give it a name, ID, like that, and the type that I want to give it. So this is going to be serial primary key, like that. Okay, let's hit enter, and the table has been altered. So if I do a /D now, if I do a /D games, you're going to see that I have the ID now, but it's an integer. And when we add the primary key, it's automatically going to add the not null keyword in there. Okay, cool. So now when we insert new data, PostgreSQL is automatically going to increment that number for us. So if I do insert into games, now I don't need to define the ID anymore. I can say just name, genre, image URL, and that's it. Like that. And the values that I want to insert, let's do Dota 2, the genre is going to be MOBA, and the image is going to be https someimage.jpg. Okay, let's close this and run this command, and as you can see, we inserted 1. Let's do another one here, League of Legends. Well, that's MOBA here. Sorry. Let's do MOBA again. And then we'll do League of Legends. There we go. And let's do one more. We'll do Overwatch. And this is a shooter like that. Okay, hit enter. And now when we try to see this, so if I do a select everything from games, you're gonna see that our ID here is auto incrementing. So good job. Again, I'll make a future episode on this to talk about the advantages of using something like PostgreSQL, like auto incrementing, or using UUID and all of that jazz. Okay, so we saw a little bit about how these tables work, how we can insert data with the insert keyword, query data with the select keyword. We also saw the delete keyword to delete a record. How can we update one? Guess what? The keyword is update for that. How simple. So we can say update, and let's say we want to update Overwatch and just change the image of it, right? Or the cover image. So I can say update, and then you give it the name of the table, so games. And then you can set whichever column you want to set. So let's say image URL, like that. So image URL is equal to HTTPS, and we'll say new image.jpg. And there we go. That's pretty much all you need to do. So when we hit enter, careful, this is going to do the same thing as delete if you don't specify a where clause. So if we select everything again, look at that. We altered all the images here. We updated all 3 records to the new image like that. Okay, so be careful with this. Same as delete. When you're doing an update, make sure you specify here the where keyword and then set, I don't know, where. So in this case, we'll select the ID, right? Where the ID equals to Overwatch. That's the one we wanted to modify. Okay, so let's just change this to overwatch.jpg like that. And hit enter. As you can see now, it's only updated 1 record. So when we select everything again, you're going to see that only the Overwatch got the new image. Okay, let's get a little bit into foreign keys and joins before I wrap up this episode. I kind of want you to know about them, be a bit more comfortable, because it might be confusing, like, what's right join, what's inner join, what are all those things do? What does a foreign key do? So let me just take you through that really quickly. But before we get into that, I just want to thank today's sponsor, Brilliant. Let's go! Brilliant is where you learn by doing, with thousands of interactive lessons in math, data analysis, programming, and even AI. I always said this in the past, and I think it's true, that the most effective way to learn something new is to just get your hands dirty with it. And Brilliant's platform is uniquely designed to build your understanding from the ground up. Each lesson is like filled with hands-on problem solving, they're really interactive, and the best part is like you're not just like memorizing facts, you're developing critical thinking and problem solving skills through these interactive lessons. This method not only helps you understand complex topics, but also improves your overall cognitive abilities. They recently launched a bunch of new courses, including one on data analysis, which I think is pretty cool. You can explore topics in there such as Bayes' theorem to multiple linear regression, using real-world data sets from companies like Starbucks and Spotify. So check out everything Brilliant has to offer. Visit the link brilliant.org/develop-by-ed or click the link in the description below for a full 30-day free trial, and you'll also get 20% off your annual subscription. So what I want to do now is just create a new table. Let's say we have users, and maybe those users can have games, right? So let's create a new table. We're going to create a new table called this users. In the parentheses, I'm going to say ID, and this is going to be a serial primary key. Okay, so I want to make sure every table has a column of ID with this serial primary key. Maybe we'll do a name as well here. So let's do name. This is going to be a varchar of 50, and now I'm going to add not null here as well. So you cannot create a user that doesn't have a name. It just will not work. Let's also add an email here, for example, and I'm going to do the same, varchar 50 not null. Okay, so there we go. That's our table. Just 3 columns, super simple. Hit enter. That's created it. So now we can do \d and say users. And there we go. We have all 3 columns activated. Okay, so what I want to do now is create some sort of relationship between these two. Okay, I want the user to maybe be able to own many different types of games. And you might have heard of these terms, one to many, many to one, many to many, all of this jazz. It's essentially how you're like making relationships between these tables, okay? You can allow a user to have many different games. It also depends like which side you're viewing it from. So if you have one-to-many relationship, that means that one user can have many games. However, from the games table's perspective, it's a many-to-one relationship, right? Many games can belong to one user. So the way we can do that, again, is with a foreign key. So we can set a specific column to kind of associate, a column with another column from another table. And that's usually, the association is with the ID. So you'd make a new column, for example, in the games table that says, hey, this game should also have a column called user ID, right? Because it can belong to a user. All right, and then many different games can have that same ID, meaning that many different games can belong to one user. Okay, so what we need to do now is essentially modify our games table, right? If we do a select all from games, we'll be able to see, well, we have name, genre, image URL, and ID. There's just like no way we can associate that with our users table here. And we don't even have any users. So let's start by creating 2 new users. Insert into users, and what we have here, name and email, I believe. So let's do values. I'll say developed by Ed, and let's also do ed.magician@gmail.com. I used to be a magician, don't judge me, it was a great time in my life. Enter. Okay, so we inserted one user there. Let's do another one. Let's do Traversy Media for the second one. Wonder how he's doing. I hope he's well. Oh, we should do a collab again. Traversy@gmail.com. Okay, there we go. We got 2 records. We have 2 users, right? Select everything from users. Boom. Developed by and Traversy Media. And then we also have our games. Okay, so the goal now, with these 2 tables, what we want to do is essentially add a user ID here in our games table, which is going to act as a foreign key. Okay, so we learned primary key. Every table should have a primary key. That's ID here and ID there. A foreign key is going to create that connection. So since we already have the table, we're going to need to alter the table, right? And add a new column to it, but that's fine. We know how to do it now. Alter table, and we want to alter the table of games. There we go. And then what we want to do is add a column, right? Add a new column entirely. And this new column is gonna be called user ID. Now what's the data type behind this? Well, this is an int, right? And the user is here. So it's gonna be the same. It's gonna be an int. However, it's also gonna be a foreign key. So let's add a comma here, and we're gonna say foreign key. Let's spell this correctly, foreign key. And then the parentheses here, we're gonna type user ID references the user ID, like that, okay? So we're adding a new column called user ID, which is gonna be a type of int. And the foreign key is gonna be this column that we added, right? User ID. And it references the user ID from this other table here, okay? So let's hit enter. Now I believe this might give you an error because you're trying to set up the foreign key without even having the user ID column added here. So what we can do instead is let's go back here and just say add column user ID int, like that. And let's hit enter. There we go. So now we have that column set up. So if we do select everything from games, as you can see, it's available right there. So now to add the foreign key, we can say alter table. We're gonna say games, and we're gonna say add constraint. And the constraint keyword is not necessary when you're gonna add a foreign key, but with adding the constraint, you can name that foreign key, which can be quite nice. So let's call this foreign key user, like that, for example. If you don't add the constraint keyword, it's automatically gonna try to name it for you. But I like to add the name. So we're gonna say foreign key. So this is gonna be the user ID column that we have in here in the games table. And that is gonna references the user ID table, like that, okay? So that's how you make that connection. That didn't work. I believe it's because we didn't say user's ID there. There we go, user's ID, right? You wanna reference the user's table. Okay, cool, so let's have a look. Select everything from games. And as you can see, nothing really changed. So now with the foreign key added, there's 3 situations we can run in when we add a new record to our games. And let me show all of them to you. So we can say insert into games. Let's add parentheses. So we got the name, genre, image URL, and the user ID. So one instance is where we pass in a user ID, okay, to a user that actually exists. So in our case, we have 2 users, right? 1 and 2, Loyae and Traversy Media. Okay, so we'll say values. So let's give that a shot. We'll give it a name, Rocket League, car game. What's the genre behind that? HTTPS, some image, .jpg. And the ID I'm gonna add is, let's add it to Traversy Media. Okay, so I'm gonna say 2 as the ID, and that's it. I'll hit enter, so that works. Okay, so when you're doing a foreign key and you have a user ID like that, everything works perfectly smoothly. And if we have a look at select everything from games, as you can see, it saved the number 2 there for the user ID. You might run in an instance. Let's go back here. Let's insert a new game where we don't specify a user ID. So let's get rid of that. And let's get rid of the number 2 here. There we go. So no user IDs have been added. The only thing I'm gonna do is change the name of the game. So let's do Apex Legends. It's a shooter. And hit enter. Do you think it's gonna break or not? So when we hit enter, it's gonna go through actually. Okay, so even though you have that foreign key set up, as long as that foreign key does not have a not null, it'll still work because it doesn't really like affect our tables in any way. It doesn't like damage the like integrity of the tables, right? There's no connection here. So you can still insert that data just fine. If you want to make sure like 100% that a game cannot be created without a user ID, then you can add a not null to that foreign key, and that way you are forced to basically add that user. Otherwise, again, that record cannot be created. But there might be another instance where you want to insert into games, and let's see what happens in this third case. So let's see, I have the user ID, but I'm gonna try to add a user ID that does not exist. So like ID with 23. Let's see what happens then. So this is where you're gonna run into the first error, where the foreign key is actually gonna stop you from doing that because you're trying to create a relationship that does not exist. We're trying to add the ID of 23, but there's no user with that ID of 23. So when you hit enter, you're gonna get this violates foreign key constraint FK user. Okay, so you're trying to create a relationship that just does not exist, and that foreign key is gonna stop you from doing that. Okay? So that's kind of the basics behind the foreign key. It allows you to create these relationships. And I just wanted to show you these 3 instances to kind of help you clarify like what it allows you to do and what it does not allow you to do. Okay, cool. So now that we have that set up, let's try to maybe insert another game here. Let's do it to develop by Ed. So I'm gonna put the ID of 1 and the game is gonna be Stardew Valley. And let's just cover joins quickly before I go. So Stardew Valley. And this is like a, I don't know the genre, well, let's just say a cozy game like that. I hit enter. Okay, so that worked just fine. Okay, so now we have a couple of different records in here. So we have in the games, we have all of these, right? We have 5 or 6 of them. And another thing I want to point out, if we delete a record, so if I delete League of Legends from here, the IDs are not gonna like re-index themselves. They're not gonna be changing to 1, 2, 3, 4, 5, 6 again, like reorder themselves. Because again, it's really important that the IDs never change, because especially if you have relationships connected and all that, if the ID changes, then all those relationships would break. Okay? Okay, so there's all the games. Now, there's all the users as well. Now, what if we want to combine these two, right? Because sometimes you might want to return, hey, I want to get the user and display it on my UI. Like, hey, this user has all these different games bought, for example, right? So the way we can do this is with joins. And you can imagine joins as kind of like taking 2 tables and kind of generating a new one and combining them together to give you a brand new one. So let's have a look at how we can do that. So we can do the keyword select, and I'm going to add the keyword join. Okay, and what I'm gonna join here is gonna be the users table, right? And I'm gonna say the keyword on. This is a new one we haven't seen before, and the criteria I wanna compare them to basically is gonna be on this user ID. So I can say games.user_id equals to users.id, like that. If I hit enter, this is only going to return me 2 records. Okay, so join by default is an inner join, and I'll show you in the graph how this kind of works. But as you can see, it only returned the the records that have some sort of relationship between the two, between games and users. So I have one game, right, Stardew Valley, and Traversy Media has another game, Rocket League. But all the other games kind of got pushed out. And even if I had a new user in here, so insert into users, let's see, we have a name and email, right, the values, let's do a new one, Josh tried coding, comma, josh@gmail.com. Okay, so let's close this up, enter. If I do that, select everything from games and join users on games user ID equals user ID, I'm still only gonna get back these 2 values. And the way I like to visualize this, let me just bring you in Figma for a second. So when you do a join, it basically by default does an inner join, really. And what that means is, so you have all your games here, right? You have 6, 20, 15, whatever. And then your users here, you have 5, 10, whatever. Basically, when you do an inner join, the only thing that gets returned is the data that kind of belongs to each table, right? So if the games already has like a user ID associated with it, only that data gets returned. So in our terminal, you can see that the other users didn't get returned. So all of this got left out. Right here, we have Josh tried coding. Bless you, Josh. You've been left out, but it's for SQL, okay? So I hope you understand. And all the other games got left out as well because they don't belong to a user. So when you do an inner join, it only returns all the data that's associated between these 2 tables. Okay, now there's four types basically here. So this is probably the most common one you're gonna do, just a simple join, an inner join. But you might also have like a left outer join, for example. So left outer join. And the way you can do that is by just saying left join, like that. And what that does essentially is it brings back all the data that's associated between the 2 tables, but also everything on the left. So all the user is still gonna get returned, even if the data is not belonging to like any games. So this is kind of how it would look. This would be bright now, and then this would kind of just like go on top of it. So everything within the circle and out here would get returned. So if we have a look at this, if I just go back here and just add a left here and hit enter, as you can see, everything on the left got returned. So it depends like what you're querying from here as well. So I'm saying select everything from games. So when I say left join, it's gonna return everything from the games first, right? On the left side here. And as you can see, look at that, we get back all the games, even if there's no relationship set up here with the user ID. Okay, so you can imagine you might have an example with like photos. Photos could belong to some users, but some photos might just be photos, okay, for the website or whatever. So that's how you would return that. If we do the other way around, so if I do a right join, the complete opposite would happen. So right join, as you can see, that's the complete opposite. It would return all the users, regardless if they have any games belonging to them or not. So now we get Josh back as well. So now everything gets returned here on the right side, and then here if you have the relationship, that gets returned as well. If you don't, then it will be just left as not null. Okay, and the last one that we have is just going to be a full join that gives you just back everything. Okay, so if I do full join, see, it gets back all the users and all the games table as well, and just jumbles it up within one like that. Okay, now again, this kind of just like returns back everything from it, so we can format this as well if we want. So let's just do the full join, that's fine. But maybe I only want to get here, not just that, maybe I want to get the name, the genre, but see how we have ID here and another ID here? that gets a bit confusing. So you can also rename these if you want. So this is, what is this? This is the games ID, right? So I can do games.id as, this is a new keyword, and then I can rename it to anything I want. Game ID, for example, like that, game ID. Okay, so I'm returning that. I can add a comma, I can get back the genre, the name, and the image URL, for example, and the name. So if I hit enter, oh, we messed something up. I said name twice here, so let's get rid of one of the names and hit enter. And as you can see, it says name is ambiguous, and I'm glad this happened because, again, we have two columns here with name, so we're gonna need to rename these. So let's just head back here. We already renamed games ID. Let's also rename games.name as, let's just say game name and add a comma. And I can also say users.name as user name, like that, for example. Perfect. Let's add a comma. I'm gonna get rid of this last name here because we clarified it, and let's hit enter. And look at that, we renamed pretty much most of the columns here. So now I have a game ID, which is a bit more clear. We have game name and then the user name. Okay, so the way you return this, you can kind of format it any way you want. Okay, so hope you enjoyed this episode. I'm gonna leave it there. There's a lot more on SQL. I hope you enjoyed the series. We're gonna get into aggregation and grouping. There's lots to learn about dates and times and indexes as well. And there's much more on foreign keys as well. So, and like tuning and whatever else. So thank you so much for watching this episode. Please drop a like and a subscribe. I appreciate that. Check out Ultimate Next.js for my latest course. I'm hard at work on building on my platform as well. I might do some videos on that. I'm really excited what's coming. Okay, I'll leave you there. Have a lovely day, and I'll catch you next time.